Hi gang, good morning. What we're doing today is we're doing circles. As you can see, the first day. I have a picture of a circle here with all the definitions on the left, so please follow along and write as we go along. This here is a circle, and we name a circle by its center. And the center here is point P. So when I go over here to write a circle, this is the symbol. It's a little baby circle with a dot in the middle. The center is point P. So when you go to name your circle, I would name it as circle P. And there are different parts to our circle. The first three we're going to talk about are the radius, the diameter, and the chord. These three are segments in our circle. What's a segment? It has two endpoints, okay? So let's look for a radius. A radius is a segment whose endpoints are the center and a point on the circle. So here is the center P. So any segment coming out of P and ending on the circle is a radius. So segment PT, segment PM, and segment PS. Those are three that are on this picture. Segment PM, segment PT, and segment PS. There are others that exist but may not be drawn. For example, segment PB is a radius, it's just not drawn. Okay? When I have more than one radius, I call them radii, R-A-D-I-I. So there are three radii in this circle P. What is a diameter? Well, it's also a segment whose endpoints are on the circle, but it has to go through the center. So segment ST is a radii because it goes, a diameter, because it goes through the center P. So this is a segment with its endpoints on the circle, and it has to go through the center. That would be segment ST. Again, another segment is a chord. And guess what? A diameter is a type of chord, because all a chord has to do, it has its endpoints on the circle. A diameter has its endpoints on the circle, but their stipulation is it has to go through the center. So a diameter just has to have its endpoints on the circle. So the chord. So the diameter is a certain chord. Segment ST is a chord, but it's also a diameter. Segment AB is a chord. Its endpoints are on the circle. And that's it. That's drawn on the circle. Others exist. Segment TM, segment TB, segment TA, but they're not drawn. So now that you understand segments, there are three types in a circle: a radius, a diameter, and a chord. We're going to go on to lines. There are two types of lines in a circle. There is a tangent line. It touches the circle once. And a secant line that touches the circle twice. So our tangent line touches the circle once. Which line touches the circle once? This line right here. Do you see my pen? That is a line, and it is touching the edge of the circle in one spot. Point M is the spot. So we name the tangent line as a line with arrows, and you can pick any of the two letters on that line. I will pick EG. Line EG is a tangent line. But notice, point M is where they touch, and that is what the point of tangency is. It's where the tangent line touches the circle. There are no other tangent lines in this picture. There are, however, some secant lines. Secant is a line that touches the circle twice. Do you see line ST? Yes, that's a diameter. As a segment, it's a diameter. So this section that I shade is a diameter. That section that I shaded is also a chord. But if I name it as a circle and extend the ends, It has now become a secant, ST. How about segment AB? How can I make chord AB into a secant? Well, all you have to do is add arrows because it makes it a line. I would just extend and extend. That chord lies inside of the secant. Okay, let's talk about diameter. How do I get a diameter's measure? Well, you do 2 times the radius. And how do I get a radius? The measure of the radius is the diameter divided by 2. You cut it in half. Formula for circumference. Diameter times pi. Cherry pie's delicious. Area, r squared times pi. Apple pie. No, apple pies are 2. Look at that. Can remember it that way. Congruent circles. Their radii have the same length. Radii have the same length. For example, here's a circle, and here's a circle. This radius is 5. This diameter is 10. The radius here is 5. What's the radius here? To get the radius, you take the diameter and divide by 2. So the radius is 5. So these radii are equal. So if I label this circle A and this circle B, I can say circle A is congruent to circle B. Why? Because their radii are the same length. Or diameters, doesn't matter. Let's talk about concentric circle. Con, meaning with in Spanish. Centric, center, with the same center. These are circles with the same center. A bullseye. Your eyeball. They're concentric circles. Now let's talk about tangent lines and their properties. If you look, I have a tangent line here. If I were to draw a radius or a diameter and it would touch this tangent line, what do you think would happen? Well, they would form a 90-degree angle. What if I made this into a diameter? It would still form a 90-degree angle. If this is a 90-degree angle, these 2 segments or lines are perpendicular. Okay? So anytime you see a radius come down and touch a tangent line, you make a right angle. Now notice, what if I did this? What do you see here? A right triangle. So how are you going to solve for missing parts? You're going to use the Pythagorean theorem most likely. All right? And let's talk about ice cream cone. Yum, 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 yum. Well, if you had an ice cream cone, if I turned it this way, I would want these 2 tangent lines coming from the same exterior point to be congruent. Why? Because if they're not, your ice cream's going to fall out. So the ice cream cone is 2 tangent lines from the same outside point are congruent. Hence, the ice cream cone. All right, turn your page. So, we're going to go through the classwork worksheet. You can tap in a minute.